Jnanam paramam dhyeyam. Knowledge is supreme.
Welcome to this course on advanced transition metal organometallic chemistry. In our foray into looking into various kinds of transition metal complexes of different ligands, mainly of sigma and pi type, we have looked into a wide variety of such ligands starting from cyclopropenyl to butadiene to cyclobutadiene, cyclopentadienyl, benzene, C6 cycloheptatriene as well as cyclooctatriene type of ligands. And in that backdrop, we are going to take up a new topic today, which is transition metal complexes of another type of ligands. These are heterocycles. So, these are heterocycles containing nitrogen, phosphorus, oxygen or sulfur. So, these heterocycles also can form pi type complexes with transition metals, and we are going to take up these transition metal pi complexes of heterocycles in the context of our studies which were done with transition metal complexes of other cyclic ligands. So, to begin with, we are going to take up the heterocycles of sulfur, selenium and tellurium complexes of metals. So, we are going to be talking about metal pi complexes of sulfur, selenium and tellurium heterocycles. Though thiophene is isoelectronic with C5H5 minus, but it behaves more weakly basic like that of benzene. So, this is an interesting consideration. Though thiophene C4H4S or thiophene, which is what it is popularly called, is isoelectronic with C5H5 minus ligand, or rather cyclopentadienyl ligand, CP ligand. Thiophene is more weakly basic, but behaves as more weakly basic like benzene. So, this behaves as more weakly basic like benzene, and that is kind of understandable because CP being anionic is much more basic, whereas thiophene being neutral is certainly less basic than what CP would be, and hence a neutral thiophene ligand also is kind of similar to that of benzene, which itself also is a neutral molecule. Now, thiophene, if one were to look at the molecular orbital involving the pi orbital which are there in the aromatic ring, one would see that the orbital degeneracy which is present because of various symmetry elements present in the C5H5 minus or C6H6 ring gets lost. The symmetry elements are no longer present, and hence the orbital degeneracy is removed in thiophene or C4H4. So, unlike C5H5 minus and C6H6, the orbital degeneracy is removed in C4H4S. So, there are subtle distinctions between C5H5 minus, the commonly called cyclopentadienyl anion, and the thiophene C4H4S, though they are isoelectronic in terms of the pi electrons are concerned. So, these are iso-pi electronic. To be more precise, this can be called as iso-pi electronic. That is what it is more appropriately be called as. And this distinction arises from their lack of charge in thiophene, as opposed to be C5H5 minus being anionic in nature, which is what it is more basic. Thiophene is less basic, thiophene is neutral, C5H5 minus is anionic, and thiophene pi orbitals does not have any degeneracy. The degeneracy is lifted or removed, lost, whereas in C5H5 minus there indeed the orbital degeneracy is present because of the presence of symmetry elements. So, then we are going to see some of the methods of preparation of these sulfur based heterocycles, and the first example involves preparation of half sandwich complex from thiophene. So, we are going to be talking about preparation of metal pi complexes of sulfur heterocycle, and the first preparation involves of half sandwich complex. And the reaction involves is thiophene at 85 degrees centigrade minus 3 CO, and this reacts with chromium hexacarbonyl, giving the thiophene half sandwich complex of chromium now. This distance of chromium to thiophene, this is about 220 picometer, whereas this distance of chromium to carbonyl is much shorter at 177 picometer, and that sort of indicates that there is a considerable amount of back bonding which happens from chromium onto the acidic carbonyl ligands, and thiophene being less basic. So, it is not acidic. So, thiophene donates electron density onto the chromium, and that electron density is further sucked in metal to ligand pi bonding by these 3 carbonyl atoms, which results in the observation of much shorter chromium carbonyl distance in thiophene chromium tricarbonyl complex. Now, this chromium tricarbonyl adduct of thiophene, however, even is less stable than that of benzene. Even though thiophene sort of behaves similar to that of the benzene in terms of coordination to metal carbonyls, but that is not exactly the same, but it turns out that MCO3 adduct of thiophene is less stable than MCO3 adduct of benzene. So, the metallocene, interesting example, metallocene analog of this can also be prepared, thiophene, and the reaction is direct reaction from tetramethyl thiophene with FeCl2. We are going to be discussing that in detail. So, this interesting example which is metallocene analog of C4H4S can be obtained by treatment of FeCl2 plus tetramethyl thiophene, which is twice of that, Me4 C4S, in presence of AlCl3 in cyclohexane C6H12, gives this tetramethyl thiophene metallocene complex of iron, and these two being neutral ligands. So, overall there is a dicationic charge, and so this is a nice demonstration where the metallocene analog can be prepared for the thiophene or substituted thiophene by direct reaction involving FeCl2 and Me4 C4S. Similarly, mixed thiophene cyclopentadienyl ligand can also be obtained from the from a ruthenium complex. This is also an interesting reaction that eventually gives rise to mixed ligand C4H4S C5H5 ruthenium complex, and the starting precursor is this cyclopentadienyl ruthenium tris acetonitrile species. When treated with thiophene, in dichloromethane and heat, gives this Cp ruthenium thiophene cationic complex. Now, it is of these two mixed ligands, Cp is anionic, ruthenium bound to thiophene is neutral, and hence it is quite logical that a neutral ligand like thiophene bound to ruthenium is more labile than the Cp in this complex, because Cp being anionic, ruthenium is in +2 oxidation state. So, this is more tightly bound, whereas this is as compared to this is relatively less tightly bound, and then this thiophene ligand is more labile than the Cp ligand in this complex. So, that is an observation which sort of can be rationalized quite easily by looking at this mixed ligand complex, and then taking into account the neutral or the anionic nature of the individual ligands. So, thiophene is more labile than Cp in this complex. So, this is a brief discussion on the sulfur based heterocycle pi complexes of transition metals, and then we are going to look into the nitrogen counterparts of these heterocycle. So, in the sulfur, before I proceed, in the sulfur based heterocycles of transition metal, what we had seen is that the sulfur based heterocycles are neutral, less basic, and they have their orbital degeneracy lifted, and that are even their adduct of metal carbonyls are even weaker than that of the benzene's adduct of metal carbonyls. And also they can be used to prepare half sandwich complexes, or that of even the sandwich metallocene counterpart, or even the mixed ligand type of complexes. So, they are quite versatile in the preparation of all the three types of complexes. Now, with that we finish our discussion on this sulfur based heterocycle, and then start on with the transition metal complexes, pi complexes of nitrogen based heterocycles. So, these are prepared from pyrrole anion. So, in this case, the nitrogen based heterocycles, one has to remember that the pyrrole anion is isopi electronic with Cp ligand. To remember, okay, and this is given in this by this reaction, where a manganese half sandwich complex has been prepared by direct reaction of pyrrole with Mn2CO10 giving pyrrole bound manganese complex plus H2 plus 4 CO, and this is commonly referred to as Azacyclopentadienyl complex. So, this ligand is commonly referred to as isocyclopentadienyl ligand, or so, this can be directly prepared from the pyrrole, or even from this pyrrole anion from iron precursor. So, the first synthesis that we had seen involved direct reaction of pyrrole with manganese chloride. The other synthesis involved synthesis from preformed preparation from preformed pyrrole anion. or C4H4N minus. The synthesis is a very simple reaction between Cp C5 H5 Fe CO2I plus sodium salt of pyrrole anion, giving eta 1 bound iron carbonyl pyrrole, which at 40 degree centigrade loses 2 carbon monoxide to give this mixed ligand complex of iron Cp pyrrole anion, and this compound in light greater than 500 nanometer and carbonyl gives back this eta bound pyrrole. So, this is a nice compound which mixed ligand compound which can be formed from Cp iron dicarbonyl iodide with preformed pyrrolyl anion and giving eta 1 bound Cp iron dicarbonyl pyrrole, which on heating eliminates the 2 carbon CO molecules and give this mixed as a azacyclopentadienyl iron mixed Cp azacyclopentadienyl iron complex, which is a mixed pyrrole Cp iron complex. It is a neutral complex and kind of similar to that of the metallocenes that we had spoken about, but only the fact that these 2 ligands of the metallocenes are 2 different ligands. So, another interesting example are these Tetraazaferrocenes. So, in the previous example what we had seen that it is a sandwich complex where one ligand was Cp, the other one was as a pyrrole, one was Cp and another was a pyrrole ring. So, now the next reaction that we are going to be talking about is about the preparation of azaferrocenes. By that what it means that both the ligands of these sandwich complexes are pyrrole based heterocycles. So, this is produced by an interesting sequence of reactions which I will be talking about. So, we are going to be look at preparations of azaferrocenes. And the preparations starts from FeCl2 reacting with tetramethyl pyrrole preformed pyrrolyl anion. So, 2 Me4 C4N Li, similar to the tetramethyl thiophene that we had seen for in case of the pi complexes of thiophene in THF, and second water giving this tetramethyl N hydrogen bonded N C4 Me4. So, these are tetramethyl pyrroles semi 4, and then this when treated with Me2S BH3 gives this azaferrocene and this one is isoelectronic with Cp star to Fe. So, here is a synthesis of azaferrocene, where both the heterocycle forms a sandwich complex of with iron. And one another interesting reaction of the same theme was made with the substituted more sterically binding substituted pyroles, and that the reaction involves MCl2, M equals iron, cobalt and nickel plus 2,5-T-butyl H2C4N Li, the preformed lithium salt, that would give this T-butyl N T-butyl M as a ferrocene with T-butyl and T-butyl substituents. Now, it is important to see that unlike the previous example, where the nitrogen lone pair had to be protected by extended binding to BH3, Lewis acidic BH3. In this case, because of the presence of two bulky T-butyl group flanking the nitrogen lone pair on that pyrrole ring, such protection is not required, and thus this azaferrocenyl derivative of this substituted pyrrole can be obtained. So, with this I would like to draw a conclusion on today's lecture. We have looked into two different kinds of metal pi complexes of heterocycles containing sulfur and nitrogen, and what we had seen that these the sulfur which is that of thiophene, they are pi isoelectronic with C5 H5 minus, but being neutral they are less basic and also have their orbital degeneracy lifted, and then they form weaker adducts even as compared to that of benzene. And these thiophene complexes can be used to make half sandwich complex, or their tetramethyl substituted thiophene can be used to make the corresponding metallocene derivative, as well as we had taken an example where one made the Cp thiophene mixed complex of ruthenium. Along the same lines, we have also taken up these nitrogen heterocycles or pyrrole based systems, and what we had seen that they can be pyrroles directly can be used with metal carbonyls to produce these half sandwich type complexes, metal carbonyl pyrrole, or they can be used in this preformed anionic state, that is potassium salt of the pyrrole, and then treated with iron to give these mixed iron Cp pyrrole compounds. As a ferrocene type molecules for the less hindered pyrrole for the tetramethyl substituted pyrrole could be prepared. However, the nitrogen lone pair had to be protected with BH3, and if one proceeds further and put more bulkier T-butyl substituents flanking the nitrogen lone pair on the pyrrole ring, then one can even make this azaferrocene without this stabilization of the lone pair using BH3. So, this is a nice demonstration of various chemical concepts that we see we have been studying, and what we saw that if one can enhance the sterics around the lone pair, the reactivity of the lone pair of the pyrrole ring could be lessened such that the stabilization can be isolated without any reagent. So, with this I conclude today's discussion on transition metal pi complexes of heterocycles of sulfur and nitrogen, and I thank you again for patiently listening to me in this lecture. And we are going to be taking up interesting application of transition metal organometallic chemistry, particularly a Nobel Prize winning application in the form of CC cross coupling reaction in the next lecture. Until then, I thank you again, and I look forward to taking up this new topic in the new class in the next lecture. Goodbye.